All right, everyone. So they say sometimes, you save the best for last. We did, in fact, save the best for last, in particular, the best of CCR. So CCR has a long history of publishing incredibly good work. You're going to be seeing 3 papers that were selected, and because we are at a hard limit in terms of timing for the venue, etc., we're unfortunately going to have to move right along and limit our questions. So our first speaker is Aurélien Boucher, who's a PhD student at UC Louvain in Belgium, working on network privacy and measurements, presenting an analysis of QUIC connection migration in the wild, CCR April 2025. Thank you.
Okay, so hello everyone. So I'm Aurélien Boucher, and I'm going to present the paper that was published at CCR. So it's analysis of QUIC connection migration in the wild. So first question is what is the history behind QUIC? So QUIC was introduced by Google in 2012. The draft was submitted to the IETF in 2015. And we see that before even the standardization came out, there was already measurement studies about QUIC. The first one recensed 600,000 servers. And then there was the standardization in 2021, where some people found over 2 million servers. And then there had been other studies about QUIC and parameters. And we have the first analysis of connection migration. So a bit more on QUIC. So QUIC is a reliable transport that works on top of UDP and that is integrated with TLS. And it's designed mainly for HTTP3 multiplexing, which helps to address some flows of TCP, such as head-of-line blocking or other stuff. So the way QUIC handles packet is that you have simplified headers, and then you have inside each packet you have different frames that allows to separate the control information and the data information that is within streams. And so you are using connection IDs to identify the source and the destination in the connection. And it makes the connection not tied only to the IP and ports, but also to these connection IDs, which will be useful for the migration. So when you're doing a QUIC handshake, you're just sending a packet with initial connection IDs and a crypto frame that contains the TLS client hello, and then the server goes on with his own set of connection IDs and his own server hello and certificate and so on, and then you can exchange data in only one RDT. So now why we are wanting to do connection migration? So the first example is fast handover. So imagine you have your phone and you have your home Wi-Fi if you have the 4G or the 5G. And so if you're moving out of the house, the quality of the Wi-Fi will decrease. And so you want to have handover to the 4G and so on. And so you can do path optimization. If you see that the latency is increasing, you change the path, you do the migration. And so there have been work on that. But that's not the only application. There are also applications for privacy and security. So there have been work proposed for protection against an eavesdropper that would do fingerprinting on traffic. So that's also something that's important to keep in mind. So how does the migration mechanism works itself? So it uses some QUIC frames that are called new connection IDs. And by exchanging these additional connection IDs, you can start seamlessly a new connection with these connection IDs using path challenge that will help to validate the path that it can be used, that there is no interference. And the advantage of using these connection IDs is that they are encrypted, so you can't link them if you're just eavesdropping on the connection, which helps for all the privacy metric. And you don't have to redo the handshake. You can exchange the connection ID at any time, and after you just have to use them whenever you want to trigger the migration. So now for the main part about the migration measurements. So it's also important to understand why we would want to do some measurements. So usually when there are new proposals that are using migration or multipath or things like that, they take it for granted that the server will use them, and they often rely on control environment where you have the control of both the client and the server, so you can make it work. Another thing that is important to notice is that for most QUIC implementation that support the migration, it can be disabled. So you can't really just do a classification of the implementation saying it does support migration or it doesn't, because sometimes it does support migration, but on the server, the option is disabled. So you can't really just do the implementation coverage. And also what we wanted to do is to understand the real-world deployment of the migration, so we can build real-world applications on top of it that will fit in the current state of the internet. So in order to perform our measurements, we use the really standardized methodology by now, which is in 3 main steps. So the target acquisition, the stateful scanning, and then the data analysis. And for the stateful scanning, we required to have the migration, which was the big challenge of this work. So now to go into detail, so how did we do the target acquisition? How can you find QUIC servers in the wild? So the main step, the first step, is to use an IP address collection. So for IPv4, it's kind of easy because with the current tools, you can scan the whole IP address space. For IPv6, we need to rely on hitlist. And what we do basically is we use ZMap to send QUIC handshake packets, and we are looking for a QUIC handshake response from the servers to know that they are responsive to these kind of packets. And then in the modern internet, if you want to connect to a server, most of the time you will have to have the name of the server, the SNI, to be able to connect. So in order to collect this SNI, we gathered domain names from the top list, so at Trenco, and also some domain files that contains a lot of domains, and resolve them with massDNS in order to have a huge map of domain with IP addresses that matches them. And with this map of domain to IP address and IP addresses that are responsive to QUICs, we could gather a large amount of responsive address with domain name associated that we could do handshake for. And so for the stateful part, so we took this set of addresses that had the domains, and we had to use a scanner to test the QUIC migration on them. So basically what the scanner had to do is to support the QUIC handshake and then a QUIC migration. And also we have looked at services that are working on top of HTTP3. So the existing version of the QUIC scanners, they were typically in the Go language. And the problem was that at the time, the QUIC Go library had no support for QUIC migration. So what we decided to do was to start with the Cloudflare quiche implementation of QUIC. And so we built a tool on top of that. So it's written in Rust, and it tests the handshake and the migration for QUIC. And then it reports the information that he found for each target. And we have the tool that is open source. And so the last part for the analysis, we wanted to identify the main providers for QUIC. So we took our scanning reports that were just this IP and this domain support QUIC or support the migration, and we tried to identify which provider was behind it. In order to do that, we extracted raw data from BGP and CAIDA AS2.org dataset, and that allowed us to do a mapping from an IP address to a provider. And with that, we applied it on our scanning, so we could group our IP addresses by their providers. In terms of the setup, so how did we perform the scan? So we used VMs in different cloud environments. We started with a cloud at our own university in Belgium. And then because we were afraid that the results from the DNS and such would be affected by the geo position of the scans. We also try to have VMs in another cloud in the United States, where we also perform the scan, so we could check that the results are indeed sound. And so, yeah, we made sure that the scan, because we were scanning real servers, were no harmful, so we put rate limits, we put opt-out list, and we had web page on all the VMs to ensure that nobody was harmed. So in terms of support, so we found that the results were consistent for both VMs, with some slight differences that are explained in the paper if you want to have a look. So what's interesting is that, so without the SNI, so if you don't have the name of the server, you have very low success, which was expected. Like if you try to connect to a server, you don't know the server name, you fail, basically. And we have more target for IPv6, but with less providers, so it's like more centered in a few RSs that have a lot of QUIC servers. And for the migration part, we can see that the support is quite high, with 52% of the server scan supporting it for IPv4 and 78% for IPv6. So in terms of providers, how does it look like? So here we have the graph for the number of targets, the number of successful QUIC handshake, and the number of successful migration. And one thing that we noticed is that for the providers, some of them are software as a service. So for example, Hostinger and Cloudflare, they are hosting the websites, but they are like providing the transport layer. And so the results are consistent between the handshake and the migration. So all the servers have the same configuration regarding migration. But some of them are more like hardware as a service. And so it's more likely other people that are hosting their own QUIC servers. And there the results are not quite consistent between the handshakes and the migration. And so these are the results for IPv6. And the issue that we had for IPv6 is that the 3 top providers account for like 97% of the target. So it's heavily skewed towards the 3 top, which are Hostinger, AWS, so Amazon and Cloudflare. So to conclude and to wrap up, so we built a new measurement tool for the QUIC migration. It's working on top of the Cloudflare Quiche library, and it measures the support of migration. The tool is open source, so you can check it out on GitHub if you want. We also use the tool to realize the first connection migration support, and we see that the migration is not fully deployed, but it's kind of good looking. And we already have some follow-up work. So we use the tool to gather targets for defenses against DDoS attack, and this is a work that was also published this year, so you can also check this. And that's it for me.
Thank you very much.